What if the grand story of the Persian Empire, its shahs, poets, and conquests, is only the final chapter? What if the true identity of the Iranian people is a far more ancient tale, written not in stone or scripture but carried silently in their blood for over 10,000 years? This narrative uncovers the enduring legacy of Iran's first farmers, a heritage more resilient than any empire and more profound than any recorded history. The very name, Persia, conjures a magnificent procession of images: the sprawling Achaemenid Empire stretching from the Indus to the Danube, the philosophical fire of Zoroaster, the intricate beauty of Isfahan's mosques, and the transcendent verses of Rumi and Hafez that have captivated hearts for centuries. This is the Persia of history, a civilization defined by its grandeur, its artistic triumphs, and its profound spiritual and intellectual contributions to the world. It is a story of powerful shahs, of epic conflicts with Greeks and Romans, of the transformative arrival of Islam, and of a cultural resilience that endured through Mongol hordes and the passage of millennia. This rich, well-documented history, however, often overshadows a much deeper, more ancient question: who were the Persians before Persia? Before the rise of Cyrus the Great, before the first lines of the Avesta were composed, before even the first cities rose on the Iranian plateau, a different story was being written, not in stone or scripture, but in the very fabric of human DNA. The modern Iranian, whether walking the bustling streets of Tehran, tending fields in the Caspian lowlands, or residing in the ancient city of Shiraz, is a living vessel of this older narrative. Their genetic heritage is a tapestry woven with threads that stretch back far beyond the dawn of recorded history, predating the empires, the religions, and even the collective memory of the peoples who would one day be known as Iranians. It speaks to a time when the world was being reshaped not by armies, but by the slow, inexorable spread of agriculture and the establishment of the first settled human communities. This genetic story is not one of dramatic replacement or conquest, but of remarkable persistence. It reveals that the grand superstructure of Persian civilization, its languages, beliefs, and empires, was built upon a biological foundation of immense antiquity and stability. To understand the soul of Iran, one must look past the glorious facades of Persepolis and the intricate tilework of the Shah Mosque and venture into the deep past, into a time recorded only in the silent, enduring language of the human genome. This is a journey into the Neolithic revolution as it unfolded in the rugged Zagros mountains, a journey to meet the ancestors whose legacy has proven more lasting than any empire. It is a revelation that challenges our understanding of identity, suggesting that the roots of a people can lie not in the celebrated moments of their historical zenith, but in the quiet, foundational epics that preceded them, hidden in plain sight within the cells of every individual. This unseen prelude is the story of the land itself, and of the first people who called it home, whose genetic echo resonates powerfully in the Iran of today, a testament to a heritage that is as ancient as the mountains that first nurtured it. This deeper narrative does not diminish the achievements of historical Persia, but rather provides them with an even more profound context. It suggests that the cultural efflorescence of the Achaemenids or the Sasanians was not the product of a new people arriving on the scene, but the culmination of millennia of human presence and adaptation on the plateau. The genius of Persian statecraft, art, and philosophy was nurtured in a population that had been tied to this specific landscape for thousands of years before they ever built an empire. This genetic continuity represents a silent thread running through the entire chronicle of the region, an anchor of stability in a sea of historical change. While dynasties rose and fell, and languages and faiths shifted, the fundamental biological makeup of the people remained a constant, a deep reservoir of shared ancestry. This understanding transforms our perception of Iranian history from a series of discrete chapters into a single, epic, and unbroken story, where the protagonists are not just kings and prophets, but the countless, nameless generations of farmers who tilled the soil and passed down their genes. The grandeur of Persia, then, is not merely in its golden cups or royal inscriptions, but in this incredible human endurance, a 10,000-year-old story of survival and persistence that is carried forward into the 21st century. The story of civilization is often told as a saga of great migrations, of invasions that toppled kingdoms, and of new peoples imposing their will, their language, and their genes upon conquered lands. The history of the Iranian plateau, at first glance, seems to fit this dramatic model, having witnessed the armies of Alexander the Great, the Arab conquests that brought Islam, and the devastating incursions of the Mongols. Yet, beneath this turbulent surface of historical change lies a staggering biological truth, a story of profound continuity that rewrites the very narrative of Iranian identity. Archaeogenetic research, a field that extracts the secrets of the past from ancient bones and compares them to modern populations, has unveiled a remarkable fact. The overwhelming majority of the gene pool of modern Iranians, somewhere between 70% and 90%, is not a product of these historical upheavals. Instead, it is a direct inheritance from a people who lived long before the first empires were even a dream. These were the Neolithic farmers of the Zagros Mountains, the rugged range that forms the western spine of modern-day Iran. More than 10,000 years ago, in the fertile valleys and foothills of these mountains, these ancient ancestors were protagonists in one of humanity's greatest revolutions, the invention of agriculture. They were among the world's first farmers, cultivating wild barley and wheat, domesticating goats, and laying the groundwork for settled life. This was not merely a change in subsistence. It was a fundamental reshaping of the human experience, leading to the birth of villages, the concept of property, and the population boom that would fuel the rise of cities and civilizations. The genetic legacy of these first farmers is the bedrock of the modern Iranian population. Their DNA has proven to be more resilient than any fortress, more enduring than any dynasty. The great events that fill history books, the rise and fall of the Achaemenids, the Parthians, and the Sasanians, the shift from Zoroastrianism to Islam, were, from a genetic standpoint, more like waves upon a deep ocean. They altered the cultural, linguistic, and religious surface, but the fundamental composition of the people, the deep genetic current, remained largely unchanged. This discovery is profound. It means that when an Iranian today looks towards the Zagros Mountains, they are looking at the cradle of their own ancestry. The connection is not merely cultural or national, but deeply biological, stretching back across 400 generations. The genetic signature of these Neolithic pioneers has persisted through millennia, absorbing later influences without being erased. It is a testament to the stability of a population that had successfully adapted to its environment, creating a demographic foundation so robust that it could withstand the shocks of subsequent history. This agricultural revolution in the Zagros was not just a local event. It was a world-changing innovation that created a new kind of human society. These early farmers were not just cultivating crops, they were cultivating a future, creating a demographic gravity that would hold firm for 10 millennia. Their success meant that the Iranian plateau became a populated, settled land early in human history, making it less susceptible to being completely overrun by later, smaller groups of migrants. The legacy of that first harvest is therefore not just in the crops that still grow in the region, but in the very cells of the people who live there today. It is a silent, biological inheritance that tells a story of deep roots, of an unbroken chain of descent from the very dawn of agriculture. For many years, the story of agriculture's spread was told as a single, monolithic event radiating out from the Fertile Crescent. A key part of this narrative was the expansion of Anatolian farmers who moved west into Europe around 8,500 years ago, bringing agriculture with them and fundamentally transforming the genetic landscape of that continent. It was long assumed that the farmers of the Iranian plateau were simply the eastern branch of this same movement. However, groundbreaking archaeogenetic studies, particularly those focused on ancient remains from sites like the Ganj-Dar Valley in the Zagros Mountains, have shattered this simplistic model and revealed a far more complex and fascinating picture. The genomes of these Zagros Neolithic farmers told an astonishing story. They were not closely related to the Anatolian farmers who colonized Europe. Instead, they were a genetically distinct population with a unique ancestral signature. The analysis pushed their divergence from the ancestors of the Anatolian farmers, and by extension, from the ancestors of most modern Europeans, back into the deep mists of the Paleolithic. The genetic lines leading to these two pioneering agricultural groups had split from a common ancestor some 50,000 to 77,000 years ago. This is a staggering timescale, implying that for tens of thousands of years before either group had planted a single seed, they were already on separate evolutionary trajectories, inhabiting different regions and accumulating distinct genetic characteristics. This revelation fundamentally changes our understanding of the Neolithic Revolution. It was not a single event, but at least two independent, parallel developments emerging from two different source populations. While the Anatolians were domesticating their own local strains of wheat and barley, the people of the Zagros were doing the same with theirs, each group solving the puzzle of agriculture in their own way, in their own homeland. The Ganj-Dar revelation means that the genetic foundation of the Iranian people is not an offshoot of another population, but an autochthonous development deeply rooted in the soil of the plateau itself. This deep ancestral split helps explain the unique biological profile of the region. The people who built the first farming communities in Iran were not recent arrivals from the West. They were the descendants of hunter-gatherers who had likely inhabited the Zagros region for millennia, a population that had been genetically isolated from Western Eurasia for a period longer than all of recorded history. This discovery adds another layer of depth to the Iranian story, emphasizing its unique and independent origins. It was a distinct cradle of civilization, not just culturally, but biologically as well. The people who would eventually build the Persian empires were the inheritors of a genetic legacy that had been shaped and molded in the Zagros Mountains for an immense span of time, a lineage separate from and parallel to the one that would give rise to the civilizations of Europe. This ancient divergence is a key piece of the puzzle, explaining why the genetic story of Iran would follow such a different path in the millennia to come. The Bronze Age, roughly from 3,300 to 1,200 BCE, was a period of tremendous upheaval and transformation across Eurasia. One of the most significant events of this era was the massive expansion of pastoralists from the Pontic-Caspian steppe. These people, associated with the Yamnaya culture were master horsemen and chariot builders who swept west into Europe, east into Central Asia, and south towards the Indian subcontinent. In Europe, their arrival was cataclysmic for the existing populations. Genetic studies have shown that the Yamnaya migration resulted in a massive demographic turnover, with as much as 70 to 90% of the existing genetic stock being replaced by the newcomers. This event fundamentally reshaped the continent's genetic and linguistic map, bringing Indo-European languages and a new ancestral component that is still dominant in most of Europe today. Given the scale of this expansion, one might expect a similar story to have unfolded on the Iranian plateau, which lies directly south of the steppes. Yet, remarkably, this was not the case. While the steppe migrations washed over Europe and Central Asia, the Iranian plateau stood like a great island of stability, a genetic fortress that remained largely unbreached. The ancient Neolithic signature of the Zagros farmers, which had been established for millennia, persisted through the Bronze Age with only minor new additions. The reasons for this resilience are likely complex, involving both geography and demography. The formidable Zagros and Elburz mountain ranges, as well as the vast central deserts, would have presented significant barriers to large-scale migration from the north. Furthermore, unlike the more sparsely populated regions of Neolithic Europe, the Iranian plateau was already home to a dense and well-established agricultural population. By the Bronze Age, sophisticated urban civilizations, such as those at Susa and in the Jaraft region, were already flourishing. These settled societies would have been far more difficult for nomadic groups to displace entirely. Instead of a demographic replacement, the interaction seems to have been one of limited admixture and cultural exchange. Genetic analysis shows that the plateau did receive some modest new influences during this period, primarily from two sources: Caucasus hunter-gatherers from the north, who likely trickled in over a long period, and some gene flow from the east, connecting the plateau to the Great Indus Valley civilization. These additions, however, did not erase the ancient foundation. They were threads of new color woven into an existing, robust tapestry. This genetic stability, during a time of continent-wide flux, is a defining feature of Iran's deep history. It meant that the people who entered the Iron Age and would go on to form the first Persian empires were, by and large, the direct biological descendants of the first farmers of the region. While Europe was being genetically reforged, the Iranian plateau maintained its ancient continuity, preserving a Neolithic legacy that had already become its defining characteristic. The narrative of the Bronze Age steppe migrations is typically one of outward expansion of the Yamnaya and related cultures spreading their genes and languages across Eurasia. It is a story of the steppe shaping the world around it. However, a deeper look into the genetics of the steppe pastoralists themselves reveals a fascinating and unexpected twist, a crucial detail that reverses the conventional flow of influence. The Yamnaya people, the very engine of this massive Bronze Age transformation, were not a purely steppe population. Their genetic makeup was a composite, a blend of at least two major ancestral sources. One was the eastern hunter-gatherers, who had long inhabited the steppes of what is now Russia. The other, surprisingly, was a population with clear genetic affinities to the Neolithic farmers of the Iranian plateau. This discovery is profound. It means that long before the Yamnaya began their great expansion, there was a significant flow of people and genes northward from the agricultural world of Iran and the Caucasus into the pastoralist heartland of the steppes. The farmers of the Iranian plateau whose descendants would later resist the full force of the steppe migrations, had in fact contributed to the very formation of the Yamnaya people in the first place. This ancestral stream likely flowed through the Caucasus Mountains, a perennial bridge and barrier between the Near East and the steppes. It was in this mountainous corridor that farming populations from the south and hunter-gatherer groups from the north met and mixed, creating the hybrid population that would become the Yamnaya. This Iranian farmer ancestry endowed the steppe peoples with genetic traits associated with the agricultural populations of the Near East. This interaction was not a one-way street. It was a complex interplay that shaped both sides. The Iranian genetic legacy transformed the steppes, contributing to the biological profile of the people who would go on to reshape Europe and Asia. This adds a rich layer of irony to the later history of the region. When, centuries later, Indo-Iranian speaking tribes, descendants of these very steppe cultures, migrated south onto the Iranian plateau, they were not complete outsiders. They were, in a sense, bringing back a piece of the plateau's own ancient genetic heritage. Their ancestry was a loop, originating in part from the Near East, being forged into a new composite on the steppes, and then returning to the south. This finding completely upends the simplistic model of unidirectional migrations. It shows the Iranian plateau not as a passive recipient of outside influence, but as an active agent in the great demographic and cultural dramas of the Bronze Age. The genes of its first farmers were not confined to the plateau. They were an export, a crucial ingredient in the formation of one of the most influential populations in human history. The story is not just of Iran being shaped by the world, but of Iran's ancient peoples helping to shape the world in turn. One of the great puzzles of Iranian history is the question of language. The majority of languages spoken in Iran today, including Persian, Kurdish, and Balochi, belong to the Indo-Iranian branch of the Indo-European family. Historically, it was assumed that the arrival of these languages must have been the result of a massive invasion or migration of Indo-European speakers from the Eurasian steppe, who conquered the local population and replaced them, imposing their language in the process. This model, based on what happened in much of Europe, seemed logical. However, the genetic evidence presents a stark contradiction. As we have seen, the Iranian plateau did not experience a major demographic turnover during the Bronze or Iron Ages. The foundational gene pool, derived from the ancient Zagros Neolithic farmers, remained overwhelmingly dominant. How, then, could a whole new family of languages become established without a corresponding shift in the genetic makeup of the population? The answer lies in a process of cultural and linguistic shift rather than demographic replacement. The arrival of the Indo-Iranians on the plateau was likely not a single, massive wave of conquest, but a more gradual process, perhaps led by smaller, well-organized groups of elites, warriors, or pastoralist tribes. These newcomers, though numerically inferior, may have brought with them significant advantages, such as advanced military technology like the war chariot, a new social structure, or a compelling religious ideology that allowed them to establish themselves as a new ruling class. Over time, the language of this new elite became the language of prestige, administration, and power. The local population, the descendants of the ancient farmers, gradually adopted this new tongue because it was advantageous to do so. This phenomenon, known as elite dominance, has been observed in many other parts of the world. A relatively small number of newcomers can trigger a widespread language shift without leaving a major genetic footprint. In this scenario, the local bloodlines continued, but they began speaking new tongues. The people remained largely the same, but their language changed. This explains the apparent paradox of an Indo-European speaking population that is genetically, overwhelmingly, of ancient Near Eastern origin. The cultural identity, defined by language, was layered on top of a much older and more stable biological identity. The terms Persian or Kurd came to describe peoples who spoke those languages, but their genetic roots stretched back much further to ancestors who spoke entirely different, now lost languages. This was a transformation of culture, not of people. The ancient ancestry of the Zagros farmers was not erased. It was simply given a new voice. This understanding is crucial for appreciating the complex interplay between genetics, language, and culture. They do not always travel together in a neat package. In the case of Iran, the language map was redrawn, but the deep genetic map, established 10,000 years ago, held firm. The legacy of the Indo-Iranian arrival was profound in shaping the cultural and linguistic future of the region, but it was the enduring legacy of the first farmers that defined its biological soul. In the grand tapestry of world religions, Zoroastrianism holds a unique and venerable place. Originating in ancient Iran over 3,000 years ago, it is one of the oldest continuously practiced faiths on earth, and its theological concepts of dualism, heaven, hell, and a final judgment had a profound influence on later religions like Judaism, Christianity, and Islam. For centuries, it was the dominant religion of the great Persian empires. Following the Arab conquest of Persia in the 7th century CE, the new faith of Islam gradually became dominant, and the number of Zoroastrians began to decline. Facing persecution, many clung tenaciously to their ancestral faith. A significant group fled Iran and found refuge in India, where they became known as the Parsis. Over the centuries, both the remaining Zoroastrians in Iran and the Parsi community in India maintained their identity through a strong tradition of endogamy, the practice of marrying only within their own community. This social custom was born of a desire to preserve their unique religious beliefs and cultural heritage in the face of overwhelming external pressures. However, this centuries-long practice had a remarkable and unintended consequence. It turned these communities into genetic time capsules. By minimizing admixture from outside populations, they effectively shielded their gene pool from later influences, preserving an ancestral signature with incredible fidelity. When geneticists analyzed the DNA of modern Zoroastrians from Iran and Parsis from India, they made a stunning discovery. These communities harbor one of the strongest and purest genetic links to the ancient Neolithic farmers of the Zagros Mountains. Their genomes show the highest proportion of this ancient ancestral component, with the least amount of admixture from later groups like Arabs or Central Asians compared to other populations in the region. They are, in a very real sense, a living window into the genetic landscape of Iran as it existed thousands of years ago. The history of the Zoroastrians is a powerful, living illustration of the broader story of Iranian genetic continuity. Their cultural conservatism, driven by religious conviction, led directly to a form of genetic conservatism. While the world around them changed, and other populations in Iran mixed with newcomers, the Zoroastrians became the keepers of the ancient flame, not just theologically, but biologically as well. Their DNA tells the same story as the ancient bones pulled from the Ganj-Dar Valley, a story of deep, unbroken roots in the soil of the Iranian plateau. The journey of the Parsis is particularly poignant. They carried this ancient genetic heritage across the sea to a new continent and through their steadfast commitment to their community, they have preserved it for over 1,000 years, an echo of the Neolithic Zagros resonating in modern-day Mumbai. They are a testament to the power of cultural practices to shape the genetic destiny of a people, and they provide the clearest evidence that the ancient bloodline of Iran's first farmers did not vanish, but endures to this day. The modern nation of Iran is a mosaic of diverse cultures, languages, and identities. A journey across the country reveals a rich tapestry of human experience. In the central plains and great cities, one hears Persian, Farsi, the national language. In the western mountains of Zagros, the powerful cadences of Kurdish and the dialects of the Laz predominate. Along the Caspian Sea coast, the Mazandarani and Jalaki languages are spoken. In the northwest, in a region historically known as Azerbaijan, the most common language is Azeri, which belongs not to the Iranian language family, but to the Turkic family, related to the languages of Turkey and Central Asia. Based on this linguistic and cultural diversity, one might assume that Iran is a patchwork of genetically distinct peoples, each with a separate origin story. The Azeris, in particular, might be expected to be more closely related to other Turkic-speaking populations than to their Iranian-speaking neighbors. However, modern genetic studies have revealed a remarkable and unifying truth that lies beneath this surface of diversity. When the genomes of these various ethno-linguistic groups are analyzed and compared, they do not fly apart into separate clusters. Instead, they converge. Persians, Kurds, Laz, Mazandarani, and even the Turkic-speaking Azeris all cluster together in a central Iranian genetic group. The underlying genetic heritage they share is far more significant than their linguistic differences. This shared foundation is, once again, the legacy of the ancient Neolithic farmers of the Zagros. The case of the Azeris is the most powerful illustration of this principle. Despite speaking a language whose origins lie in Central Asia, the Azeri people of Iran are genetically almost indistinguishable from their Persian, Kurdish, and La neighbors. Their genetic profile shows that they are overwhelmingly of the same ancient Iranian stock, with only a very minor contribution from Central Asian or Turkic ancestors. This is a classic case of language replacement without significant population replacement. At some point in history, likely beginning around the 11th century CE with the arrival of Seljuk Turks, the local Iranian-speaking population of northwestern Iran adopted the language of the new rulers and settlers. But this cultural and linguistic shift did not erase their deep genetic roots. They began to speak a new language, but their bloodline remained tied to the ancient inhabitants of the plateau. This discovery highlights the crucial distinction between a linguistic map and a genetic map. They are not the same. In Iran, the genetic map reveals a deep unity that transcends the lines drawn by language. It shows that the vast majority of people living within the country's borders today are members of a single, extended family, sharing a common ancestry that dates back 10,000 years. The cultural and linguistic diversity is a testament to the rich and complex history of the region, but the genetic unity is a testament to the profound stability and resilience of its foundational population. The story of the Iranian plateau's genetic heritage is primarily one of deep roots and remarkable continuity within its own geographical boundaries. However, the influence of this ancient gene pool was not entirely contained by the mountains and deserts that define the region. Over the millennia, threads from this genetic tapestry were carried far and wide, woven into the populations of distant lands creating a legacy that stretches across continents. The story of this expansion begins in prehistory. To the east, across the deserts, lay the Indus Valley, where another of the world's great ancient civilizations was taking shape. Genetic evidence has revealed a significant connection between the early farmers of the Iranian plateau and the people of the Indus Valley civilization. It appears that the same ancestral stock that populated the Zagros also contributed heavily to the populations of ancient India and Pakistan. This suggests a vast zone of interaction and migration in the Neolithic and Chalcolithic periods, a Persian Indus corridor where people and ideas flowed freely long before the rise of the great empires. The Iranian genome was thus a foundational element in two of the most important centers of early urbanism. Thousands of years later, during the medieval period, new avenues of expansion opened up via the sea. Persian merchants, renowned for their maritime prowess, established extensive trade networks that crisscrossed the Indian Ocean. They sailed their dhows down the coast of Arabia and deep into East Africa, trading textiles, spices, and ceramics. This commercial enterprise, known as the Shirazi trade, was so influential that numerous cities along the Swahili coast, from Mogadishu in Somalia to the islands of Zanzibar and Kilwa in Tanzania, claimed Persian origins in their founding myths. For a long time, these claims were seen as mere legend, a way for local rulers to enhance their prestige. But modern genetics has proven that there is truth to these stories. Traces of Iranian genetic heritage can be found in the modern populations of the Swahili coast, a clear biological testament to the medieval merchants who not only traded goods but also settled, intermarried, and left a lasting genetic mark on the people of East Africa. Perhaps the most surprising echo of this ancient genome is found in Europe. Studies of the modern population of Tuscany in Italy have revealed a subtle but distinct genetic link to the modern Near East, including Iran. The origins of this connection are still debated, but one intriguing theory links it to the ancient Etruscans, the mysterious, non-Indo-European speaking people who preceded the Romans in the region. The ancient Greek historian Herodotus claimed that the Etruscans had migrated to Italy from Anatolia. It is possible that this ancient migration carried a genetic signature with affinities to the broader Near Eastern gene pool, including the one that originated on the Iranian plateau. From the foundations of Harappa to the medieval ports of Zanzibar and the ancient hills of Tuscany, the genetic legacy of Iran's first farmers has traveled far, a quiet but persistent reminder of the plateau's central role in the great, interconnected story of human history. The history of Iran, as it is often told, is a grand drama of rising and falling empires. It is the story of the Achaemenids, who forged the world's first superpower, of the Parthians, who challenged the might of Rome, of the Sasanians, who presided over a golden age of art and science, and of the Safavids, who redefined the nation's identity. It is a chronicle of magnificent cities like Persepolis, Ctesiphon, and Isfahan, of powerful religions like Zoroastrianism and Islam, and of a linguistic tradition that produced some of the world's most sublime poetry. This history is undeniably glorious, a testament to the dynamism and creativity of the peoples of the plateau. Yet, the revelations of modern genetics compel us to look beyond this imperial pageant to find a deeper, more enduring definition of Iranian identity. The core of this identity lies not in the transient structures of any single empire or the doctrines of any particular faith, but in the quiet, astonishing persistence of a biological heritage that predates them all. The central truth is the 10,000-year-old continuity of the genetic signature inherited from the very first Neolithic farmers of the Zagros Mountains. This genetic legacy has proven to be more resilient than any dynasty and more lasting than any monument. While conquerors came and went, while languages were adopted and abandoned, and while religious beliefs shifted over the centuries, the fundamental genetic makeup of the population remained remarkably stable. This enduring core provides a profound anchor for understanding the Iranian story. It suggests that the celebrated cultural achievements of historical Persia were not the creations of entirely new peoples arriving on the scene, but were rather the expressions of a population with an incredibly deep and unbroken connection to the land they inhabited. The capacity for innovation, for building complex societies, and for creating timeless art and literature was nurtured over millennia within this stable demographic foundation. This perspective redefines the very concept of grandeur. The magnificence of Persia is not just in the gold of Darius's palaces or the intricate domes of Shah Abbas's mosques. It is in the silent, 400-generation-long chain of descent that connects a modern Iranian in Tehran to a barley farmer in the Zagros foothills at the end of the last ice age. It is a story of survival and adaptation on a scale that dwarfs the lifespan of any empire. This biological continuity is the unseen bedrock upon which the entire edifice of Persian civilization was built. It is a shared inheritance that unites the diverse peoples of modern Iran, Persian, Kurd, Azeri, in a way that transcends their linguistic and cultural differences. They are all, in essence, branches of the same ancient tree whose roots run deeper into the soil of the plateau than any historical record. To understand Iran is to understand this profound duality, a history of dazzling cultural and political change playing out on a stage of remarkable biological stability. The true epic of the land is the story of the enduring core, a testament to the idea that the ultimate identity of a people may be written not in the annals of kings, but in the silent, elegant, and timeless language of the human genome. This narrative delves deep beneath the surface of Persia's imperial grandeur to uncover a story of remarkable human continuity. It explores how the genetic legacy of Neolithic farmers from the Zagros Mountains has persisted for 10 millennia, forming the stable bedrock of modern Iranian identity. Journey through a history written not by kings, but in the human genome, revealing a heritage more ancient and resilient than any empire, a story of survival that connects the present day to the very dawn of civilization.